Hey everybody, and welcome to a very special meeting. This is a very informal chat, and basically is just us getting to know a little bit more about the technology space that we're in. So Daryl obviously works with a lot of interesting projects, and I'm thrilled to share one of the smartest people that I've ever met with you, and to get some insight from Julian on his predictions for technology in 2021. And a little bit of a summary in terms of what 2020 brought as well. So Julian, what did you do last year that you found very strange and wouldn't want to do ever again?
Well, I think the first thing that's very strange is you accused me of being smart. Nobody's been able to prove that conclusively.
We can only try, but suggestions, just saying.
Okay. Well, look, 2020 was quite an interesting year. I think if you look at the way that Amazon suddenly has come to the forefront, they've basically had one of the best years ever, and that's primarily driven by two things. There's a massive adoption to cloud, and obviously the online retail space has just exploded. The biggest trend, I think, the biggest thing takeaway that we can say is that for the first time in human history, people don't have to be geographically located at work.
Yeah.
I've read a couple of interviews. People who have accepted jobs in New York, who live elsewhere, say London or Los Angeles or wherever, suddenly they find they can't travel, but they're still working. They meet all their colleagues online, they carry on as if they were working, they're just doing it from home. And hopefully they're wearing pants while they're doing it.
We can only hope, but if Zoom fails have taught us anything, I'm not hopeful about pants. I'm hopeful about people attending formalized meetings sometimes. It's definitely been a strange year in terms of us not needing to be physically accessible, and a bigger demand on our technology to actually serve this interconnected approach. And I'm quite curious to hear from your side, at least, what tech perspectives and what languages do you think are going to be the ones that we build this new world on?
So languages are, I'll add anything I say here with a bit of a disclaimer to say that you need to take this based on today's information. The problem always when you look at new technologies, especially if you're looking at programming languages, they're incredibly difficult to make any concrete predictions on. The best you can look at is take kind of historical trends and see what's happening in the market right now. To put everything into perspective, for any programming language to succeed, it needs a reason to succeed. It needs an application effectively. So if you look historically, Swift and Objective-C is a great example, because before the Apple iPhone came along, the only people using Objective-C were the very, very small group of people who had Macs. After that, obviously the whole Apple ecosystem became more widespread, and suddenly you see this explosion of Objective-C programmers. The only reason for Objective-C to exist currently is to serve the Apple ecosystem. And that's with any technology, right? There are some amazingly incredible programming languages, but a lot of them just go nowhere because they don't have anything that'll push market adoption to any extent. If you look at it, one thing to make clear before there's any predictions is that the historical market drivers behind our existing platforms are still there. .NET is still the premier programming platform for the Windows ecosystem. Java is still the primary development platform for enterprises. So there's still a lot of work. Those aren't going to go away very soon. It's many years ago, and I'm talking now more than 15 years ago, Java was described as a new COBOL. And COBOL is kind of starting to die now, but there's just so much momentum behind it that it's never going to truly die in any sense. It just becomes less relevant over time. So new technology won't be the first pick, and that's really how a language slowly over time starts to die. And anything that's any C# or any Java thing is going to stay like that. So if you have kind of hitched your wagon to one of those horses, then you're still going to be okay. Okay. As for what's happened in the greater industry beyond that. The two big things that have kind of come up in the last decade are JavaScript and Python. JavaScript, obviously, because it's the programming language of the web, the browser specifically, and it's kind of, if you've ever noticed, there's a trend in software for consumer technologies to find their ways into the enterprise. This is true of Windows and DOS and Mac to a certain extent. And what's happened in the JavaScript space is it's moved from the browser into other avenues. So it's become a cross-platform development toolkit for doing mobile apps, and it's become obviously ubiquitous on browsers, and it's being used for server applications in the form of Node.js. Python's great claim to fame is its use in the data space, the big data space. So, because of its incredibly simple syntax, you don't need to have a very in-depth knowledge of programming in order to master it. So you don't need to know anything about fancy type systems or typecasting. You do, but not in the depth that we might work in it. Furthermore, the type of problems that you're solving aren't necessarily the type of problems that require a massive amount of engineering. So you don't need to have a background in software engineering or software development as a whole in order to work with the language. And Python managed to many years ago come out with a statistical library that's sort of become the standard for data science. And so much so that Python has superseded Java as the world's most popular programming language. I think that was last year, and these things depend on the index that you look at, but generally it's considered now that Python is more popular than Java. It's also become the premier learning language for a lot of the universities, especially in the US. Many years ago, MIT replaced Lisp with Python as their primary learning language. So all MIT students, for example, get taught, engineering students get taught Python. Okay. So it's got wide adoption in the educational space as well, and then it's the default scripting language for Linux and Unix administration. So it owns that market for all intents and purposes. Now that kind of takes care of what's currently on the horizon and what's there at the moment. Yeah. Now, if I want to gaze into my crystal ball and look at what is going to happen with emerging technologies, again, one needs to look at the application. So if you see an emerging language, one of the things you have to look at is where are the potential applications for this thing, and is that application something that's going to see wide adoption? Many years ago, well, not that many years ago, 2014, Apple released a programming language called Swift. Now, I like Swift. I really like Swift. It's sort of a very cleaned up version of Java and C#, from a clean base for the most part, although it also has some legacy it needs to deal with. And they open sourced the platform, made it available. It is going to become the premier programming language for the Apple ecosystem. Okay. Now, Apple did open source it, and it is available on other platforms besides Apple, but Apple themselves have no real incentive to really use it as a language across different different platforms besides Apple. So at the moment, I don't see much of a future for Swift beyond the Apple ecosystem. But it will gain popularity purely because of the Apple ecosystem. And for us, for relevancy for us immediately, unless we're doing the type of mobile applications or Mac development, there isn't really a need for us to go out and learn Swift, for example. It's not something I would say, look, unless you are a mobile dev, you need to know Swift. Looking on the server side, things are a bit more interesting. So years ago, I think it was about 2009, 2008, I can't remember the exact year, Google released a programming language called Go. It was developed by pretty much the same guys, bar one guy, a guy called Dennis Ritchie. The guys who developed Google Go were Brian Kernighan and Rob Pike, who were co-creators of the original Unix kernel and C. And their intent with it, with Go, was basically to create a better C, to take their 30-odd years of experience about working in the C programming language, and then looking at how they would actually take the best parts of C and create a new system programming language that encapsulates those things, but deals with some of the problems that you encounter. Years ago, I read a thing about somebody described C as basically somebody created a gun that shoots in both directions, and not happy with the carnage, they decided to invent C. So C basically Go tries to take the unsafetiness of C and create safety around that. So that's much easier and safer to build predictable programs that you can basically reason about. Now, interesting thing about Go is that it's been quite slow in growing. If I look at something like Swift, for example, and part of the reason for that is that it hasn't really had the type of interest or the type of application that something like Swift has, because obviously Go isn't aimed at, for example, the consumer market. You can write Android programs in it now, but historically you wouldn't have. And on the server side, you already have a wide array of choices, and you're going up against big competitions, most notably Java and C#, for example. And those platforms are established. There's a big ecosystem, so it's uphill going. However, with the emergence of microservices, one of the trends that has happened is that you don't need to have these big runtimes, or you actually don't want these big runtimes. You want an environment that you can scale out easily, scale up and scale out quickly. So if you're spinning up new containers, you don't want to wait 10 seconds before that container actually comes online and joins into your cluster. And one of the benefits of Go is that it's a natively compiled language, so it's very fast compared to the likes of Java and C and C#, especially in startup time. So it's very cheap to go and create a big cluster of Go services. And basically spin up, scale them out horizontally. Interestingly, Go has also been used to build a lot of these microservice enabling technologies, most notably Docker and Kubernetes. So both Docker and Kubernetes are written in Go. So it's found a niche in the systems programming space, and people are using it to develop a lot of these DevOps tools and these tools to create these runtime platforms. And slowly but surely, it's starting to gain traction on the server side. So last year, I remember that Alan Gray, for example, they've adopted Go. I'm not sure if it's still the case. Actually, that was 2 years ago now. Yeah. Whatever the case is, they adopted Go, And one of the reasons they cited was just the fact that compared to some of the other choices, it uses a lot less resources, and they can scale it up a lot quicker than something like Java or C#, which has to carry around this big virtual machine and environment and runtime and everything. So I would say if you are on the server, Go is certainly something that you should be keeping an eye on. Whether or not it'll score the big one and become the dominant programming language, I don't know. It's hard to say. I personally don't think so, but I can't say that for sure. Like I said, it's certainly something you should keep an eye out though, and then if you can add it to your CV, I think you should. Then there's a corollary to Go that's worth also keeping an eye on, and that is a programming language from Mozilla called Rust. And Rust basically tries to solve the same problem that Go is trying to solve. So you have a history of systems programming languages like C, which comes with a whole lot of things you have to deal with that you don't always want to deal with all the time, like memory management, and you can create very unsafe programs and. So Rust basically is playing in the same space that Go is trying to play in, and that is to create a better systems programming language. It's actually quite an interesting language. So whereas Go is very simple, there's nothing special about the language per se. Rust actually brings a whole bunch of new concepts to the table. And certainly if you're a programming language snob, chances are pretty good that if you had to choose between Go and Rust purely on the features, then I would guess most people would probably choose Rust. It's also found a bit of a niche in the systems programming space and the DevOps space. I remember Chef a couple of years ago, they started writing some of the utilities in Rust. I've seen it pop up a lot in newer kernel designs. I believe that Microsoft is looking at it as a replacement for some of their systems programming. And Google is looking at it, I think, for the Fuchsia OS. They used Rust quite extensively there. So that's also something that I would say at the moment is keep an eye out on, and if you can learn it, do it. But it's hard to say whether or not that's going to be the next thing.
Yeah. Now
that's sort of the server side. Now there's changing track, going into the mobile space. There's also some developments happening on that side. So many years ago, this is another Google language. Google released a programming language called Dart. Dart had no real purpose at the time, or the purpose that Google had for it was quite poorly defined. If you want to give them the benefit of the doubt, and consequently there was no real traction or real adoption in any serious form. The language itself is nothing spectacular either. One thing that Google seems to like is to keep the design of their languages very simple. So they rather than sort of loading your programming language with features, they will rather take concepts that are pretty well understood and pretty well known, and rather use those for their languages. To them, it seems that syntax is less important than application, which is actually not a bad philosophy. But if you're a programming language snob, Dart's not going to be where you necessarily want to play. It's not bad. I mean, it's got some nice features, but it's not up to, say, like a Kotlin or a Swift or one of those languages. So it's languished, but recently, possibly because of the whole Oracle lawsuit with Google, they introduced a programming toolkit called Flutter. And Flutter is basically a a whole mobile development toolkit that is cross-platform. So you can write Flutter apps for the desktop, you can write them for iOS, and you can write Flutter apps obviously for Android. And really, it's actually quite a good platform for developing on Android. And certainly, what's quite nice about it is that it does seem to solve some of the problems that some of the other cross-platform mobile development tools encounter. And this is something that has been gaining quite a lot of interest lately. Flutter is still relatively new, so it's still quite early on its adoption curve. But certainly, it's something that if you're doing front end, you should be keeping an eye out on, because it's something that appeals to Google's market of trying to get more people onto Android. And certainly the feedback that Android devs are giving is that this is actually quite a nice toolkit to develop on. And the fact that you can create cross-platform apps on this is a big bonus, especially if you're an enterprise developer or anything like that wants to give the customer a native experience, but at the same time not have to duplicate the development effort for different mobile platforms. So that to me is actually one of the languages that I would seriously keep an eye out. And I think if it keeps going at the rate of adoption that it's currently going to be going, there's currently going in, it's definitely something that we should be adopting at some point. Especially if you look at how big the Android ecosystem has become, it's going to be a very important platform going forward at some point.
Yeah, absolutely.
In terms of everything else, I think something that was hyped up, looking at things that probably won't gain any more attention than they already have. I would put Kotlin in that bracket. So Kotlin basically became the alternative language for building applications for the Android platform. It's very easy for any Java developer to pick up Kotlin. The problem is that it doesn't seem to be getting too much attention outside of being an alternative to Java on Android. So while there has certainly been adoption for Kotlin for building Android applications, there isn't enough value for people outside of it to seem to want to pick it up over something like Java. So my prediction here, and I'll go out on a limb here to say that I think Kotlin is something that's going to stall, and it's not going to go any further. And obviously, with Flutter coming around, it does. I think that the focus from Google is going to be to develop their Flutter toolkit as opposed to the existing kind of Android stack that they have at the moment. So Go is also going to develop for running on Android, so that's also another reason that you should keep an eye on Go. But it makes sense for Google to take both of their programming languages and platforms and actually push development for Android on them.
Yeah.
Okay. Then there's also the also-rans. So I would put Ruby and Scala on the also-rans. Ruby, obviously, about 10 years ago, it was enjoying a lot of adoption because it made web development very simple. It also was used quite extensively for scripting and in the DevOps space a lot. But it's sort of, it doesn't really add enough value, and it has a lot of negatives to it that simply don't make it really valuable for development outside of that. And it's showing in the numbers because people aren't really adopting Ruby. Scala was gaining traction in the data and the big data analysis space, but it's kind of also stalled because of Python. You don't really need much more than Python actually to do big data. And even R, which was a language specifically designed to do data analysis, is kind of losing traction in light of Python, because Python is ubiquitous and it does the job just fine, and it's easy and simple. And one of the indicators of the success of anything is the simplicity of it. So if people can adopt it easily, they will. And Python has got a very low barrier of entry compared to some of the other technologies. And then there's an honorable, in closing maybe, there's maybe an honorable mention in mentioning TypeScript. So I think of all the programming languages that Microsoft has released, I would give TypeScript as the one with the brightest future. Firstly, because it's become the default programming language for doing Angular, and Angular is the leading JavaScript framework for doing web apps. And obviously there's other frameworks that have adopted it for doing mobile as well. And second of all, there's an emerging platform for server-side JavaScript using Google's V8 engine called Dino. Dino is written by the same guy who wrote the original Node.js engine. And what he's tried to do is he's rewritten the whole engine effectively using TypeScript and using a lot of the JavaScript features that weren't available when he originally did Node.js. So there's definitely potential for TypeScript both on the client side and the server side, and certainly, I mean, we do already do a lot of TypeScript at Darrell. Obviously, if you're doing any Angular dev, you're probably doing TypeScript already. Yeah. But just keep an eye on TypeScript in the server space as well, server-side space as well, because there's a possibility that it could actually start gaining more traction based on the adoption of Dino.
Absolutely. I think the interesting part in this is how things sort of come full circle. I know that especially for some of the smaller independent career boot camps that are training people to get into engineering quite quickly, they almost skip over quite a lot of it. They start with Python, and once your Python is at a good enough level, you are released into the wild to sort of go and upskill yourself as well. So now a couple of questions just from a practical perspective. If you had to advise people, would you advise them rather to go into the Go direction, or would you prefer them to rather go into Rust? What would be your first sort of port of call there if they had to choose one of the other?
Okay, so I mean that's quite a broad question. So I'll take a step back and say, well, those programming boot camps basically teach you the absolute basic skills you need in order to go and find a Python job. First of all, that doesn't make you a very good programmer. One of the things that you should actually be learning is the basics of what programming is. So do you know your different programming constructs? If you're doing traditional imperative programming, you have sequence, selection, and iteration. Those are kind of universal across all programming languages. So do you know the basic principles of what makes up the art of programming? If you understand that, then you can actually start divorcing yourself from the actual technology, and you can actually start evaluating these things from yourself. Now, if I were to say if you were to choose, the biggest thing really is, like, are the jobs out there? So if you decide that you want to pick Go, for example, the easiest thing to do is, are there jobs out there? Okay, can I look at the language and very quickly, based on these basic skills I have, of these basic principles rather, can I actually go and learn this very quickly, no pun intended? And I think that's an important skill to learn generally. And the idea really is to say, well, if I need to change, can I change quickly? And if you know enough about how programming as a skill works, then you've put yourself in a good place that you can retrain yourself very quickly. The one thing, obviously, is that the problem to that is that generally most of the programming languages, they're not just pure languages anymore, that they're platforms. Yeah. And that's really the biggest thing that you have to struggle when you are learning a new programming language. It's not so much the syntax of how things work, but the actual platform behind it. Once again, the easiest way to learn a platform is to have enough knowledge of how platforms work in general. So the concept of packages and namespaces, and these days even package management systems. All those things are skills that you should have in order to be able to learn a new platform. Yeah. I remember years ago, I did a foray into coding for Apple. So I wrote an iOS app, and basically you look at I could take the language and I could take principles that I'd learned over the years in working in things like C and Java, and I used those same principles to learn how the platform worked. First of all, what's the paradigm of the programming language? Is it imperative? Is it functional? Is it hybrid? Is it an OO? Is it an object-based language? If I can mark off those things, then what are the characteristics of that language? Any language will come with a set of libraries. Where are those libraries? How do I link those libraries into my system? How do I compile against those libraries? And finally, how do I actually take and create an executable binary that I can use to deploy for this programming language? And with those type of skills, if you apply that type of mindset, you can basically take any platform and learn it quite quickly as well.
Yeah, absolutely. I think it's sometimes the benefit and the downfall of the software engineer is this ability to apply these things, and that's sometimes how you end up doing a whole bunch of things without really finding something that you're super passionate about. But having that awareness allows you to experiment and find what works for you and where you want to ultimately end up. It's probably not a bad thing if you are going where the employment is right now and tailoring your journey from that point onwards. You might end up doing something and realize, hey, this is completely out of the scope of what I want to do, and pivot and know that that's not actually worth your time and worth your effort.
Yeah.
Alrighty, it's been very interesting. I will say it's coming off of the back of a year where suddenly everybody wanted all of their technology to integrate and to be as low touch, low interaction as possible, and suddenly
no friction.
Not even a little bit. It's interesting to see how these things change but don't change as much as you'd expect them to. Thank you. I really appreciate it.
It's my pleasure. Thank you.